Differential equations where you have a derivative, usually in Leibniz notations, and you separate the differentials and integrate, right?
Right.
Right. Okay, now, there are some very famous differential equations. The most famous is the one we're going to talk about right now. Consider this fairly age-old problem. Joe starts with $10 at time 0, and he adds $1 every year. That would imply that at time 1 year he has $11. At time 2 he has $12. Yes, he's getting rich really, really slowly. What kind of growth is this?
Linear.
It's linear. The rate of change is constant. All right then. We can see in a table a rate of change is constant if the change in y over change in x ratio is always the same. All right, so that's linear. Good enough. Lou here is much smarter with his money, and he invests with 10% interest earned. Let's start with time 0. He has $10. At time 1, he has $11. At time 2, he has $12.10. Okay? And so each time, if you recall back from pre-algebra, you could find the new amount one of two ways. What's one way to find the new amount? You're making things really complicated. How would you explain it to a pre-algebra kid? To find the next amount, you would need to find 10% of the previous amount and then add it. Okay, what's a shortcut to finding 10% and adding it to 100%? 10% and multiplying by 1.1. Either which way, you would see that the next would be 10% more is $1.21. On top of that is $13.21. Certainly then, the rate of change is changing, which graphically would make the curve do what? Curve. If the rate of change is different, then it curves. Oops, that's 1.1, sorry. 1.21. What? Oh, so it makes a curve. Now, the rate of change here, we can see that when we show the difference here, for Joe, the rate of change is constant. So that would imply that if I were to write that as a differential equation, dA dt is constantly 1, yeah? Okay? dA dt for the Lou guy, well, surely that is not constant because those rates of change are variable. What do they always relate to? The amount. All right, so they always relate to 10% of the amount. So we could say they're always some proportion of the amount at any time, or they're proportional to the amount. Would you say that? Directly related to the amount. The rate grows. It grows at a rate related to the amount. To see how much it's going to grow, I would need to know the amount of that. Yeah? All right, now, while that might not seem like a big deal, okay, great, dA dt equals Ka. Well, it actually yields a super duper famous idea of mathematics. Are you ready? Hold on to your shorts here. You ready? If you're not wearing shorts, then hold on your pantalones or your skirt or whatever. I hope you're wearing something along those lines. Okay, so if you have dA dt equals Ka, and we want to solve the differential equation, the intent being, rather than talking about the rate at which it's growing, instead to get an account or an amount equation. So I can say, in 5 years you have this much. That's about rate of growth, not about amount you have. You with me? Well, to get the amount I have equation, I would need to integrate, and before that I would separate the variables, yeah? So dA over A equals the constant I suppose you could put on either side, but I'm going to keep it on the right side. Cool? Cool. All right, so if I integrate both sides, I get. That's what I said, dt. Ha. Is that better? Okay, so now if I integrate, I get natural log of the absolute value of A equals kt plus some constant. Variables all over. So no big deal. All right. Now, I want to do two things. I want to get an A equation, so I want to solve for A, and I also want to put in an initial condition to get that C. Now, normally I say put in the condition right away to get the C, but you'll see that it'll pay off if you wait a little bit here. I'll show you why. I'm going to wait, and I'm going to now start to solve for A. All right, so the first thing I do is exponentiate. So the absolute value of A is equal to e to the kt plus c. Now I'm going to do a little bit of exponent cleanup on this. Wouldn't you say that e to the kt plus c is the same as e to the kt times e to the c? In the exponent rule, say if you multiply two things, you add the exponents if they have the same base, right? Okay. I think I would prefer that e to the c to be out front because it's a constant. I'll make that my coefficient. So that I'm just changing the order. No big. Cool? All right. Absolute value. When you dump absolute value, what happens? You consider the other thing could have been plus or minus in that. So e to the c, e to the kt, like that. All right. Now, at that point, this is starting to get ugly. The constant now is really ugly. No offense. So let's try and make it clean. Okay, now I don't really have an initial condition given, so I'm going to really make one up here. I think you'll agree that just common sense says at time equals 0, the amount would equal the initial amount, or A naught. I mean, that's what A naught means, the amount at time 0. So I'm going to use that as my initial condition. If I plug in for A then, A initial, plus or minus e to the c, that big mess is just going to stay there. And e to the kt is now going to be e to the 0, which will be 1 in the thing. Now that would mean then that plus or minus e to the c is just A initial. So that big old mess of plus or minus e to the c, I could replace this big mess, this whole thing, with A naught. So if I go back to where I left off, then I'm going to put in that place A equals A naught, or A initial, e to the kt. And you just derive the equation for exponential growth. It comes from the fact that the amount grows at a rate proportional to the amount at any time. All right, so you need to understand this on 3 levels. You need to move smoothly, interchangeably from one to the other in order to solve problems given them with these. You need to know the amount equation. Now that's not usually an issue. You've been dealing with that forever. You need to know the differential equation associated with it, which is if they give you the rate of change in the amount is equal to the proportion of some proportion of the amount, then that means exponential growth or decay. And you also need to know the verbal description. If they give you a sentence that reads, the amount grows at a rate proportional to, I will say proportional to the amount at any given time, then that's code for exponential growth, and you need to go straight there. So let me give you, let's look at 2 common multiple choice types of problems, all right? Are you with me? So, say you're given this question. Bacteria in a certain culture increase at a rate proportional to the number present. If the number of bacteria doubles every 4 hours, in how many hours will the number of bacteria? Now you can see then that subtly, maybe not so subtly hidden in here, is that they don't say, like a pre-calculus problem, the amount grows exponentially. They're saying the amount grows at a rate proportional to the amount. It's on you to understand that implies this relationship. And go there with it. Okay? After that, then it starts to become like a pre-calculus problem. So just by way of review, will you crank that out and we'll compare answers here to make sure that you remember, not to insult your intelligence, but just to review your exponential solution methods. Okay, are we ready? Oh, calculator, calculator. Okay, sorry about that. Okay, so I would say if it doubles, then the amount goes from 1 to 2. So did you get a k of natural log of 2 divided by 4? Okay. Triple then would be 3 to 1, e to the, whatever, I'll call it k, but I found k, and I'm looking for t. 3 equals e to the kt. You could do this a lot of ways, but I took the natural log of both sides. Time then is natural log of 3 over k, or if you like, natural log of 3 divided by natural log of 2 over 4. Agree? Do you all agree? Okay, yeah, because they're 4-hour. Okay. All right. Consider this one then. Temperature changes according to the differential equation. Okay, big mess. Where k is a constant and t is measured in minutes. At time 0, f equals 180, and at time t equals 16, f equals 120. Now you can see then, if you don't have these ideas or these equivalences in your head, then I guess the option is to start to integrate that and go about it in as solving the differential equation, which is a major time eater. But hopefully you look at that and say, oh, so the rate of change is proportional, or is a constant times the amount of the thing itself. That tells me that I can use exponential growth equation. F equals F initial e to the kt. Yeah. They give me F initial is 180. So I can plug that in. I can plug that in. Yeah, I can plug that in. I did plug that in. And then at time 16, F is 120 would allow me to find K. What the heck is that about? Can I copy it? I did. Okay. So be it. 180 e to the k T. I can, without even seeing the answer to this, I know K should be, oh, I guess all the answer choices are negative. Darn it, never mind. I was going to say K should be negative, but how do I know K is negative? Because it's decreasing. That's exponential decay. Yeah, so I know you got a negative K there. That's what's causing it to decay. But after that, you're solved. So far, so good? All right, that's exponential growth in a nutshell. Now let's move to set 89, average value function. Here we go. Tammy, how you doing? Look like you're struggling to get to the finish line of the week, sister. Hey, you don't look very happy. This. Okay. All right. Tell me, can you average the numbers 88, 92, 84, 96, and 90?
Yes.
Mentally? 3 seconds. Go. 90. Ah. Do the what?
Take 2 from 92 from 88.
Yeah.
6 from 96 from 84.
Yeah, this is 2 below 90, and this is 2 above 90.
Got 3 minutes.
And this is 6 below 90, and this is 6 above 90. And so, if you split the differences, it is 90. True that. Okay? Now, graphically, you're so confused? If it's the average, then it must, the difference of all the belows the average must cancel out or zero sum with all the differences above the average. So I imagine she said, it looks like 90's in the middle somewhere. And then you could get into it and say, well, that would be 2 below 90. That's 2 above 90. So that would be cool. They would average 90. And this is 6 below 90. That's 6 above 90. Those typically knock each other out. So these two together really make a 90. That's together make a 90. So it's a function of really 90.
Oh, so it's just 10. I like
Okay? And that's actually how I average a class at papers. I just say it looks like about 90. And I say 2 below, 2 above, 3 above, 3. And I just, rather than average the numbers, I average the difference, the sum of the differences. Takes no time, and you can do it mentally. Now, if you imagine this visually, we are looking at scores between 80 and 100, yeah? And I suppose 88 would be about here, and 92 would be about there. And 84 would be about here, and 96 would be about there, and 90 is here. Now, we took a stab at 90 and said, okay. Now in terms of distances, those of you in stat can appreciate least squares regression and all that good stuff you guys learned. But in terms of distances, this distance of 2 below gets knocked out by this distance of 2 above. And this distance of 6 below gets knocked out by 6 above. And that's on the line, so that's no distance. Now, in the end, then, the distances, the negative distances, must equal, at least in absolute value, equal the positive distances. You follow? If that's truly the average, that should always happen. The amount of differences below should cancel out the amount of differences above. We. Okay. Now imagine then if instead of those finite number of points, I had more points. Say I had a point that was this much below, and there was a point that was this much above. And maybe there was a point that was this much below and this much above, so that I could actually draw a curve. Oops, darn it. I missed at the very end. All right. Now, if I then had segments to all those, all the segments, that's plural of segments, by the way, all the segments below, if I found all those distances below, they would be exactly the same as the positive versions of all the segments above. And so you could say the area below must equal the area above, the average. You follow? Okay. Well then, let's continue. That's where the average value comes in. Now this is going to blow your mind. If I if I just said, hey, average these numbers, and then I started listing the numbers, and I spoke forever, could you average them? Yeah, you could. Oh, so cool. Okay, so here's how it would go. Imagine f of x is this curve here. Obviously, it has infinitely many points, and therefore infinitely many y values associated with those points. If I were to find the average value, it would have to be somewhere in between all the y values. So somewhere, like all averages, has to be somewhere in between. So I'm going to say it's roughly in there somewhere, yeah? One of those points, not all of those. Okay? Now it's a y value, so let's call that f at, I don't know, it's not at A or it's not at B, so what should we call it? Let's call it f at C. Good idea. All right. So let's call it f at C, where C would be this point where the average value is. Now, if I were to then compare the two areas I see, now two areas, I'm not referring to these two areas. I'm actually referring to the area under the blue curve and the area under the average value line. Okay? You follow? Here's that area, and here's this area. Now, if this negative area truly knocks out that positive area, then how should those areas relate? They should be equal. They should be equal. That area. Area 1 equals that area 2. Okay. How would you find that area? Integrate from A to B. How about this area? Now we can integrate that, but because it's just a straight up rectangle, it'd be easier to just do geometry. What's the area? F at C times is the height times the base is B minus C. All right. Now all that's great, but I don't really particularly care about, the original question wasn't, hey, compare the areas of these things. The original question was, what's the average value? Well, where is the average value in this statement? F at C. So to solve for F at C, you could say that it is the area under the curve divided by the base of the graph. B minus A. All the y values divided by the region of x values is the average y value per x value, or for any x value. Whew, that's cool. All right, so the average value then of a function on A to B can be found by that idea. Now, please read carefully when you get these problems, because there are two types of problems. I don't know if you remember back when you were just learning derivatives, but there's some growing pains that the A/B students are going through, where one time I asked, what is the average value of the, what is the minimum value of the function? In which case you are supposed to minimize, find the derivative, and do you report a y value or an x value? If I ask a y value, which you've learned through hard work, what's the minimum value of the function, means you report a y value. If, however, I ask, find the x at which the minimum occurs, then you report an x value. Now, there's the same distinction to be made with average value. Sometimes they say, find the average value of the function, in which case they want a y value or an f value, okay? However, in a second, they will ask a question something like this. Find the C guaranteed by the mean value theorem, or the x equals C, in which case you're going to find an x value at which the mean is made, or the average is made. The level of work is kind of inversely related. On the derivatives, the y value is more work, but on this, probably x value. I'll show you. Let's go back here. So if I wanted the average value of the function, I just want to say f at C, whatever that middle y value is, can be found by taking the area under the curve, the total of all, the sum of all the f values, on 0 to pi over 2 and dividing by how many are the x values? Pi over 2 minus 0. All right. So when I do that, I imagine I'll get something ugly, which is fine. I get 3 over 2 pi squared over 4 equals cosine 0 minus 0 minus 1. Something gross like 2 over pi times 3 pi squared over 8 plus 1. Equivalent. Do you agree? Do you see? Are you alive? Oh, there you go. Something. Good to know you're alive. Nate, how you doing, man?
Good, how you doing?
Good. You ready to run today? Feeling fast? What'd you have for lunch?
Some bagels.
Is that good?
Carbs.
Oh, really? Okay. Seems like a big fat bomb to me. Whatever. All right, cool. Good luck with that. I'm not going. What's that?
Gives you energy.
Does it? Is that so? You're supposed to eat carbs close to the time. So, do you eat something special the night before, like steak, pasta the night before?
Not like right before though.
So, when do you have beef jerky or raisins?
It's like after I run.
See, there's something for everybody. All right. What about baba ganoush? When do you eat baba ganoush?
All the time.
All the
While you're
time.
running. While you're running.
All right. On the back, then, let's go to existence formulas. In lower math, there are 0 existence formulas. In higher math, there are many existence formulas. That's because in lower math, you don't do proof. But in higher math, you do lots of proof. And existence formulas are almost exclusively used for proof purposes. So, would you recall some existence formulas? What formulas say there must exist a blah, 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 such that blah, blah. MBT, IBT. IBT says that there's got to be a y value between 2 other y values if it's continuous. What else? MVT. MVT says there's got to be a place where the instantaneous rate of change equals the average rate of change. EVT. There's a lot of VTs here. EVT, which is to say that a function must have an absolute min and max, assuming conditions are met. All those are theorems we use, truly, all the time. Now, in this case, must there be a place where on the curve that makes the average value? So if I have a curve like this, and the average value I say is in here, does that average value have to hit the curve? Does it have to be on the curve? F of C must be on the curve? Must be on the curve. It's continuous. Why would that be? Give me an example why that would fail. Okay? Give me a famous function that you covered last year that might have an average value, but the curve's not there. One over x. Wow, that might be good. Hi. I don't know where I put them. Oh, hey. Yeah, do you mind?
Yeah, I don't do an analysis.
Thanks.
We only have like 30s in all departments, so we have to keep wiping them out.
Okay. I hope I don't get a machine gun on your. All right. So, 1 over x is true. Let's go a little simpler. Say the step function. Okay, say this is going on here. Okay, what's the average value on 0 to 2? 0.5. And yet, is there a place on the curve where y equals 0.5? No. Okay, so you're right to say continuous. Continuous is the condition that needs to be met. And if it's continuous, then it must pass through all the values in between, and so that must pass through that halfway in between area idea. So it is about continuous. Oh, I already gave it to you. You're not brilliant. I said it right there.
I didn't read it.
Sure you didn't read it. Okay.
You call me a liar.
Now here's the unfortunate note. Here's the unfortunate title. The mean value theorem for integrals. Well, I mean, on one level it works because you're finding average value, so it's logical. Yeah.
I
I, MVT, I.
didn't know mean value.
The integral, oh yeah, the IMVT. I don't know if that's a thing. Or not. MBTI. Whatever. I will say this. If they say MVT, they say, I'm talking about the MVT, then that's implied the original MVT, not the integral MVT. That's about derivatives. So read carefully. You can see how it would be dangerous if you said f of x equals sinh. Find the c guaranteed by the mean value theorem on 1 to 2. If it didn't say for integrals, then what are you going to do? Yeah, regular MVT, it's continuous and differentiable. F prime at c equals f of b minus f of... You're going in a totally opposite direction. Okay? But if you read it for integrals, then you say, there's got to be a place. First of all, you'd say sinh is continuous. So f at c, the sinh graph looks like a cube graph, kind of like that. Steeper growing, now it's exponential. So there's got to be a place where the average value is made. Not that there has to be an average value, but there has to be a place where the average value is made. So you're actually going to work on such a problem, you work both sides. Yes, we find the average value. We say 1 over 2 minus 1, 1 to 2 of sinh. The antiderivative of sinh is cosh. And we would evaluate from 1 to 2, so we'd get something like cosh 2 minus cosh 1. And at that point, it's pretty well played out. Now, all that said, it doesn't say find the average value. It says find the c guaranteed by the mean value theorem. In other words, there is a place where the average value is made. Find it. I'm looking for an x value. All right. So on this side, I'm going to say, well, f of c is sinh of c. So I need to know a place where sinh of c comes out to that result. Well, how would you then solve for sinh of c, or c, rather? Inverse sinh. Inverse sinh of cosh 2 minus cosh 1, whatever that is. That's the x where the average value is made. You with me? Okay. So let's go here then. These average value problems often appear on AP free response questions and interpretation pieces here, along with a few others. So say I gave you the number of problems a student has to do at any time t since the first day of school is modeled by this. Now, I'm usually pretty good at writing models, but this isn't a very good model. I apologize. What would this imply? That the minimum number of problems you always have to do is? Here, 13. It's 11. Okay. The least this could be is -1. So the least this could be is -2. So the least the whole could be is 11. Okay, that would imply that the least you ever have to do is 11, and the most you ever have to do is 15, which of course is laughable. You have a way different variation than that. But like I said, I was making this up during pre-algebra, and they were making animal noises and stuff. So I couldn't. Exactly. What? That's what I said. What? Why? Just out of the blue, they're taking a test, and some kid just out of the blue just says, "Call!" Why? I don't. That's why. I'm a smart guy. I mean, I can understand stuff. I cannot understand that. Why
You ask him?
Yeah. I said, why? And he said this. I don't know. What?
Okay, guys, next test.
Why? You guys, they honestly have zero idea. I think they're like possessed. They just no idea. Whatever. At any rate, I'm glad you're you and not that anymore. That might have been you 6 years ago. I don't know. Okay, so this model isn't very good. It's my point, but I apologize. The point can still be made. If I asked you to find n of 8, n And then 8 then is 13 plus 2 sine of 4 pi, which is 13. Interpreting is a huge part of the calculus, taking your calculus and putting it into regular real words. What does that mean? I just found? At time equal 8 days. Now, that's one way to say it. What's another way to say it? If time is the time since the first day,
After 8 days.
that means on the
8th day.
ninth day. On the ninth day. Okay?
Because it includes the 8th.
Yeah, it's time since. So if I said at time 1, that's 1 day since the first day. That's the second. Right? So at time equal 8 days, the number of, well, help me out here, people. Problems this person, the student, has to do is 13. Well, the student has 13. Okay, n prime at 8. What's the derivative of that, please? N prime at 8, which I right away, anytime I interpret a derivative, I don't like prime notation. I have an easier time interpreting derivatives if I write them in Leibniz notation or rate formation, so I remind myself it's a rate of change at time equal 8. So what is the derivative? Cosine pi over 2. So the pi over 2, the 2's would go away. Do you agree? Okay, so it'd be cosine, pi cosine. Hey, guys. Pi cosine of pi over 2t, yeah? At 8, so pi cosine of 4 pi, which is pi. Interpret, please. On the 8th day, or at time equal 8 days, or on the 9th day.
The number of problems the student has to do is changing by 5 problems.
Okay, so I like that. Interpret, just general format to remind you. I know you guys do this well, but you make a reference to the time, the blank, whatever they tell you, in this case, number of problems, is you should always be intentional about interpreting the signs. So don't say changing, but rather increasing or decreasing. In this case, it's increasing. You almost always say at a rate of, then you refer to the answer with the units. So in this case, at time equals 8 days, the number of problems is increasing at a rate of pi problems per day. Okay? Okay, now the part that relates to what we're talking about today, find and interpret that expression. Actually, let's forget the find. Let's just interpret, shall we? In the interest of time. What is it? Okay, so it's crucial that you interpret this as an average number, because if you try and in your mind think, well, if I took the antiderivative of number of problems, what would that doesn't mean, that doesn't have meaning. You have to look at it as an average value. If you see a fraction out front, think average value of whatever's in here. Okay, average value of whatever you're integrating. So in this case, this is the average value, or average. Now I could say it's the average value of the number of problems, but that's kind of clunky, wouldn't you agree? What's a better way to say it? Average number of problems. It's the average number of problems the student has to do. And then obviously you have to make reference to the time frame. Over what time interval? From time to... Okay, is it enough to just say in 4 hours? Or 4 days?
Which 4 days?
Yeah, you have to specify which 4 days. So from time equal 2 days, which would represent the 3rd day, to time equal 6 days, which would actually represent the 7th day. Hi. Machine gun? Machine gun?
Dude, you're a master.
On the Scantron, it makes a noise, every time it sees a wrong answer, it makes a noise. So if you put a bad test through, it goes, just like
The
the
most embarrassing thing in the world
Yeah.
is standing in there and there's other teachers in the room.
Yeah, it basically says,
They're
it's,
going off. It's just like,
it's like being machine gunned.
said everything wrong, sorry.
I just say something like, oh, sorry, I had the wrong key for that one. It's in the copy office, yeah. Yeah, it could be real rough, I'll tell you what.
Is it because they were going to
We have kids that say, I didn't know how to bubble, they don't know how to bubble, so you have to teach them how to bubble. Whatever.
Wait, I know Mr. Mitchell, she was right for like the time as like who is less touchy. You, is it exclusive or exclusive?
Inclusive.
So you wouldn't, so it would be incorrect to say, okay, the average value of problems you have to do between days.
Between what else? Okay, between.
Even though it's it's not inclusive.
Yeah, well, the endpoint says actually, if I know that, the endpoints could be included. All right, that is that. Should we do test page 1 or homework question?
Homework question.
I want to set 87 today, if that can happen.
We're 87.
We're 87. Is that going to happen?
Yeah.
All right, test. All you have done is page 1, page 2 is a bit of a mess. Got a lot of area and volumes remaining.
It could go. Is that what he was wanting us to
I guess that's a pretty
It's 2014. I Hey, look it paid off to spend a lot of time on this first page.
The ones that will be correctable are 5 in the back.
Of my textbooks. I'm so like all of this. Oh my God. I didn't know.
That is so frustrating.
No, I don't do it now.
Yep, I will say I am confused.
All right.
Wait, you know what?
And then,
Second derivative. Wait, can you do that? Can you do? Oh, what is
there it is. Okay. So, did I say which one? Oh. Okay, 5, sorry. Talk to me about 5, people. 5, I saw this coming. It was easy to make a bad distractor or a good distractor. because people on the homework make the same error over and over again. So 5, correctable for points back. I had by far the most people that made an error chose C. They said, well, I drew my axis here, and so if it's half full, it's 0 to 1. So my integral should be 0 to 1. It seems like I'm cool. Why not?
That's a gross equation.
Yeah, I totally agree. 0 to 1 would be the limits of integration if you drew it there. But if you drew it there and you subbed for x, then what's the equation to this? It's shifted. It's not at the origin. It's
Plus y.
yeah, now it's shifted up 1. And so if you solve this for x in terms of y, it would be the square root of y minus. That's why we put the center at the origin, so we don't have this ugly circle equation. That's not there. And so that doesn't work because all the equations are predicated on it being centered at the origin. Okay? So figure out which one should be and center it at the origin, which if you center at the origin. Okay. Look at 19, just for the sake of strategy here. Okay? 19 is not correctable, but gosh, not anytime, but there are 100 times throughout a calculus test where you could go at a problem from two angles, derivative or antiderivative. If they say the slope is 2x plus 3, does that mean the tangent line equation is 2x plus 3? No, a lot of people read that as the tangent line equation. That's not what it says. It says the slope is 2x plus 3, which means the derivative is 2x plus 3. Now, I don't know about you, but I am a test strategy kind of guy, lazy guy. So right away I said, okay, the derivative's got to be 2x plus 3. That means A is out. Derivative is not 2x plus 3. B, out. Derivative is not 2x plus 3. C, in. Derivative is 2x plus 3. D, the derivative is 2x plus 3. That's in. E, out. Right away I just rolled it down to C and D because it only goes derivative 2x plus 3. After that, you can put the point in 1, 2 and answer the question. Or you can integrate y is x squared plus 3x plus c and figure out which 1, 2, which equation to make sense. All right. That is all we're going to get to. I'll give you more time to correct this on page 2 on Monday, but let me have this back. See? Give you more time. This?
Yeah, because it's the distance I hate how they felt fair and could do that. I hate how they felt like no, or like when people vote, I hate when you just like, oh,
It is not to say. I mean, 7, Make sure I get your test.
Financial office.
I knew that person was definitely not.
Okay.
So, I knew that.
Oh, you said that as, that's plural.
Yeah, that's
When I get my level, or you can.
Yeah, you're right. You're right.
What are you doing this online?
Oh, if the limit, let me pause this.
I might come here.